So we graphed a few functions, exponential functions, by using tables of values and then identified their domains, range, and then also any asymptotes. This time what we're going to do is we're going to take a gander back at those rules of transformation. And you probably remember that we were able to shift functions up, down, left, right, but then also to be able to reflect them over the x and the y axis by using rules of transformation. Just a reminder, if we add a constant to a function, that moves the function up or down. If this value a is positive, we shift it up a units. If a is negative, we're going to shift it down a units. We take a look at this value c, and if that's negative, we're going to move the graph to the right c units. And if c is positive, we're going to shift it to the left c units. And then finally, if we take and substitute a negative x back in for the x in the original exponential function, we're going to flip it over the y-axis. And then if we just take the opposite of the entire function, that's going to reflect over the x-axis. One of the things I always do is I always check with the graphing calculator just to make sure that when I get my transformations, they look okay. So let's go ahead and try to graph these exponential functions, just keeping in mind what this function f of x equals 2 to the x looks like. All right, so we probably remember that we had the point 0, 1, and we also had the point 1, 2 on our exponential function. All right, and it did like this sort of thing, and then it got close to the x-axis. So that's a really rudimentary graph of what 2 to the x might look like. And so if I was to try to graph this, okay, just by free forming it, not by doing anything too special, we have this 2 to the x plus 1. So notice that we have c is going to be positive. And so what that's going to mean is we're going to move it 1 unit left. So what that means is I'm going to take these points and I'm going to move them to the left 1 unit. All right. So instead of having the point, and again, this is the point 0, 1, if I move it to the left 1, that means I would have the point negative 1, 1. And then this point right here, if I move that to the left, that's going to be the point 0, 2. And you can imagine that we would get a function that looks something like this. Okay, now we are going to graph this by using technology, but that's just the basic idea of it. So that way, at least in our heads, we can see what's happening with this, or in our minds, we can see what the graphs look like. The domain is still all real numbers. Okay. The range, notice that it's trying to get to 0, but it can't get to 0. All right, and then it just keeps going up forever. All right, and then the asymptote is still at 0. All right, of course, we're going to graph this just to verify it. So in our graphing calculator, now be careful. If you use Desmos, if you try to do this, like 2 to the x and then plus 1, sometimes it'll jump down. All right, so what you might have to do is you might have to put it in parentheses. All right, if you're using Desmos, I would also recommend using parentheses for the graphing calculator. All right, just to verify, remember we had the point negative 1, 1. Right, and then we also had the point 0, 2. All right, so that's a way that you can verify that what you thought would be the transformation, that's what it's going to be. All right, so a few more examples. So we have 2 to the x minus 2. All right, so that's a constant. That means we're going to move the entire function down 2 units. All right, so let's take those 2 points that we had before. All right, so remember we had the point 0, 1, or 0, 1, and we're just going to move it down 2 units. Right? And then also we had the point, remember, 1, 2. All right, so we're just going to move that down 2 units, and that's going to be here. Now, we're also moving the asymptote, which is usually y equals 0. We're just moving that down 2 units as well. All right, so just imagine that we have, this is our horizontal asymptote at this point. And so the function is going to look something like this. I'm going to blow that up, and I apologize, just drawing that free form. The domain of the function is still all real numbers. Okay, so let me erase that and make that kind of look like an infinity. That would be helpful. So domain is going to be negative infinity to positive infinity. The range is not 0 to infinity. The range is going to be from negative 2 to infinity, okay? Because we're trying to get to that asymptote, that horizontal one, but it's not getting there. And then the asymptote, because we move the entire function down 2 units, is going to be y equals minus 2. Now, once again, let's verify by using technology. So we have y equals 2 to the x, and then plus 2, or minus 2, excuse me. All right. Let's also graph the asymptote y equals negative 2. All right, so there's our asymptote. If we zoom out from the function, we get that. And then a couple points that we thought were going to be on the function. Remember, we had the point 0, comma, negative 1. Okay, so that's there. And then we also had the point 1, comma, 0. All right, so that's also on the function. All right, so again, this is just to help you to remember, like as you're moving this along, what the graph of the function looks like, and also the properties. Okay, so that way at least you have a couple points that you're sure of. And of course, we could get more points if we wanted to, but with our rules of transformation, we're just trying to envision them in our heads. All right, another example, we have 2 to the x minus 1 plus 3. We have 2 transformations this time. All right, so x minus 1, remember that means that we're going to move the function to the right 1. And then the plus 3 means we're going to move up 3. All right, so we're going to take our 2 points that we had, and we're just going to move them right 1 and up 3. All right, so remember we had this stationary point 1 or 0, 1. So we're going to move it right 1 and then up 3. All right, so now we get the point 1, 4. Right, and then we also had the point 1, comma 2. And so we move that right 1 up 3, so it becomes 2, comma 5. We're also moving the asymptote up 3 units, okay? So our asymptote now, instead of y equals 0, is now going to be y equals 3, all right? And so if I was to graph this function, just kind of getting an idea, again, a really rough idea of this in my head, I'm just going to get something like this, okay? I know that's not too good, but that's about the idea of what I would have. All right, now, again, by using technology, we would have 2 to the x minus 1. And again, we probably should use some parentheses here. So 2 to the x minus 1, close parenthesis, plus 3. Right? We had the asymptote y equals 3, which makes sense. A couple points that we had, I believe we had 2, comma 5, which falls precisely on that, that curve. And then we also had the point 1, comma 4, which also precisely falls on that curve. All right, so we're getting the idea of how to graph these. A couple more examples. So we have this 2 to the minus x minus 1. So we certainly know the minus 1 is going to move it down 1. And then if the negative is in the exponent, that means it's going to reflect in the y-axis. All right, so we move the entire function down 1 unit, and we're going to reflect in the y-axis. All right, so apologies. All right. The domain of the function is always still from negative infinity to positive infinity. Okay, so that never changes. Okay, for our domain. Okay, if I were to graph this, okay, so we're gonna move it down 1 unit. Okay, so our 1 point is going to be here. Okay, so instead of 1, 0, it's going to be the origin. And then also we usually have the point 2, comma 1. All right, so now we're going to have the point 1, comma 1, but it's going to get reflected in the axis. Okay, so it's going to get reflected over here in the y-axis. And then finally, we moved everything down 1. So instead of y equals 0, the asymptote is at y equals negative 1. All right, so we have this going on. And so if I was to guess what this function would look like, okay, probably something like that. Our range is going to be from negative 1 to infinity. All right, but of course, we always want to check by using our graphing calculator. Okay, so we go over here. Let's get rid of this, this, this. And we're going to have 2 to the minus x. And then we had minus 1. Remember, we had our asymptote y equals negative 1. We had the origin. all right, which we certainly have on there. And then we also had the point -1, comma 1, all right? So those points certainly exist on this function. And so what we thought our graph was going to look like, it certainly does look like, all right? So I know reflections are a little bit more tedious to do, to graph accurately, but that's a pretty decent graph just by freehanding it. Okay. Now, last thing we're going to do is graph this function, -2 to the x. And that's going to flip everything over in the x-axis. Okay, so what's going to happen is, excuse me, our transformations are just a reflection in the x-axis. Okay, domain is always -infinity to infinity. Okay, we didn't move the function up or down. And so that means that we're still going to have y equals 0. Okay, so if I were to graph this function, just thinking about a couple of the points that we have. So a couple of the points that we usually have are these 2 points. Okay, so we have 0, 1, and 1, 2. But we're reflecting them. And so what's going to happen is we get this point right here. And then we also get the point, again, this is going to be reflected in the x-axis. And so this function is going to be asymptotic, and then it's going to do this sort of behavior this time. All right, so if I was to graph this just to make sure that that's what the function looks like, this would be y equals -2x. Okay, we have y equals 0 is still going to be the asymptote. We have the point 0, -1, and then we also had the point 1, comma, -2. All right. And certainly those 2 points fall on the graph. All right. So our range of this function, be careful, it's not going to be from 0 to infinity. It's going to be from -infinity to 0. Okay. So notice the function goes down forever, and then it's kind of getting closer and closer to 0, but it's never going to get there. Okay. All right, so those are just some examples of being able to use our transformations to be able to graph our function that's exponential. All right, so in the next videos, what we're going to do is we're going to start taking a look at being able to graph the natural exponential function and what that is. And then also later, we're going to take a look at transformations of that function.